Good afternoon. My name is Michelle Ashton. I'm the Director of Communications for the Fish and Wildlife Foundation of Florida. On behalf of our entire board and staff, I want to thank you so much for taking time out of a busy day during the holidays to join us for a conversation about habitat restoration in the Indian River Lagoon. Couple quick housekeeping items before we get started. Please double check to make sure that you're muted and you remain muted throughout the duration of our conversation today. The exception is during the question and answer portion at the end. There's two ways to ask questions. You can use the raise your hand feature. I'll call on you. You can unmute and talk directly with our presenters, or you can drop your question in the chat and I can ask it for you. That option is really helpful if you have a question that pops up during the conversation and you want to make sure you don't forget it. Really excited for this topic today. The foundation is helping to fund plantings at 11 sites in the Indian River Lagoon, thanks to donors like you. And we're going to focus on one of those sites today in the Loxahatchee. Joining me to talk about it are FWC biologists Rodney Hudson in Beecham First and Jonathan Dickinson State Park biologist Rob Rossmaneth. And I believe, Rob, we're starting with you. Rob, can you hear us?
Here we go. And all right, can you hear me?
You sound great.
Okay, perfect. Okay, almost there. All right, so all good there, Michelle? Everything look okay?
Perfection.
All right. So thank you for that introduction, Michelle. Today I want to talk about eelgrass planting at Jonathan Dickinson State Park. So this is a project that me and Rodney at WC, we essentially worked on this during the summer, and we've got a start to this project and some results. And you can see in this picture, so this was 2015, and there's a bunch of eelgrass in the river. So this is native, non-planted eelgrass, and you can see there's a little bit of a better picture or same picture without the writing a little bit later on, but there's 4 manatees here. So eelgrass is really great for manatees, but other wildlife as well, and water quality. So we'll see that in a second. And basically, I'm setting up Rodney today. I'm just going to look at where the park is, so we're in Southeast Florida. So this is a map of Florida in the bottom right. You can see that star. We're in Martin County. And so this is the yellow is Jonathan Dickinson State Park. We're about 25 miles north of the city of West Palm Beach. And we've got a ton of adjacent public lands. And we'll again see some different maps showing that. But we're relatively small, but a bunch of water comes our way through the National Wild and Scenic Northwest Fork of the Loxahatchee. And we have a ton of people that visit the park every year, primarily from the surrounding urban areas to the south, West Palm Beach, Fort Lauderdale, and Miami. And one of the focal areas of that recreation and visitation is the Northwest Fork of the Loxahatchee River. And so that's this area here. We'll look at that in more detail. And then all of that water is coming from Corbett, Dupuy, Loch Slough, Grassy Waters, Hungry Land. There's a bunch of sort of different water or portions of the watershed where all that fresh water is going to the Northwest Fork, and then it goes out Jupiter Inlet to the Atlantic Ocean. So focusing on focusing in on the park, we've got our scrub in the east, US 1, I-95 is over here, Bridge Road, Hope Sound to the north, Tequesta and Jupiter to the south. And the area of eelgrass planting is in this sort of middle reach of the river. So a lot of our visitors come through via boats, canoe, kayak from down here. That's our main recreational use area, going to Trapper Nelson's. And this is where you'll see in this slide. So these are the areas, these are polygons of Vallisneria in the 2011 to 2017 time frame. So there's about 10 to 15 acres of eelgrass, sorry, kind of just downstream of Trappers, maybe couple 3 miles downstream of Trappers. So these areas of the river are kind of open, so there's lots of sunshine coming down to the river. If you go further upstream of Trappers, it's more of a dense canopy. And these are some pictures of those eelgrass meadows in that 2011 to 2017 time frame. And you can see it's a significant resource. Lots of critters are using this eelgrass, including the manatees that we saw before. Here's that picture again. So here we've got the one surfacing, a second one to the right, and there's 2 in the background. So lots of manatees, and you can see probably they've been munching on this eelgrass, uprooted some of it. So this is kind of my final slide before I'd send it over to Rodney. But you know, what is eelgrass? Why is it important? It is a submerged freshwater plant. So it's similar to a seagrass, functions the same way. It's just more freshwater loving. And it's great cover for invertebrates and fish, especially young fish that are, you know, prey for other bigger fish. And then food for a variety of herbivores, including invertebrates, fish. You'll see a turtle picture in a little bit, and then obviously the manatees. And yeah, the goal of this project was to try to get closer to that 2011, 2017, lots of eelgrass meadows in the river. The plant reproduces either by sending out runners, then shooting up out of those runners, or with flower and fruit. So with that, Michelle, I will send it back to you.
Great. Rodney, do you want to take over?
Okay, I'm going to share my screen. Can you see that?
Not quite yet.
Okay.
Sometimes there's a little bit of a lag.
Try it again.
Well, we know it was working a few minutes ago. Here we go.
How's that?
Great. Yeah, we
Okay,
just
and
have
then
to.
go back to, let's see. Can you see that?
It's perfection.
Okay, so I need to go down to where Rob left off. Okay. I'm Rodney Hudson. I'm with the Florida Fish and Wildlife Conservation Commission. I'm a biologist in the Aquatic Habitat Restoration and Conservation section. This first slide is somewhat repeating some things that Rob previously mentioned. Eelgrass is very important habitat for a variety of fish and wildlife species, including manatees. And it reproduces in a couple ways, either fertilization of a flower to produce a seed, or in the middle photo is runners where the plant moves to different areas. And the left photo is just a healthy stand of eelgrass. Okay, so I'm going to talk some specifics about the project and our funding source and the process that we went through for the project. So we have two funding sources for this project. The FWC Aquatic Habitat Restoration Enhancement subsection, and also the foundation helped fund the project. In 2001, we were issued permits from the two regulatory agencies, FDEP, the Florida Department of Environmental Protection, and the Army Corps of Engineers. In early 2022, we entered a contract agreement with a contractor and with the foundation. And then later that year in the spring, beginning in April, was when we started the project. And overall, the project involved planting about 30,000 plants between River Mile 8 and River Mile 11 in the Northwest Fork. And then later that year in September, we did some additional plantings with a foundation contract, and did some additional, constructed some additional fences. Overall cost for the project was about $105,000. Move to the next slide. So when we were in the process of the procurement for the work, we included some specs for exactly what would be required for the planting, and there's a lot of details here, but basically we had specs that required minimum leaf height, and some specifics about the technique for planting, and of course the number of plants. And not listed on this slide, but the contract also included some pretty specific specs for fence construction. Next slide. So after the project was completed, or the plants were installed, Rob and I began monitoring of the plants. And this map shows the specific locations for each of the planted areas. We had 15 areas originally planted, and we kept track of which we had a couple of varieties of the eelgrass planted out there, so we kept track of that, and of course recorded our observations during each monitoring event. This is a photo of the contractor's at the contractor's nursery. FWC conducted an inspection of the plants before installation. So this just shows an individual peat pot, and that was in April of 2022. We'll get to the day one of planting. So it was April 28th with the contractor, and this shows the installation of the plants within one of the fenced-in areas. The fences are about 1,000 square feet and about 5 feet high from the river bottom. Here's another look of the fence. Okay, we'll move on. So this shows after initial installation, you can see the eelgrass and the peat, the peat pots in one of the fences. And another photo of the one of the planted areas right after installation. And this, so we began, like I mentioned, we began monitoring the planted sites, and Rob and the park designed some signage to let visitors know about the project. So about 78 days after installation, The plants were doing very well. This shows, this is a planted site near Trapper Nelson's. Pretty much the most upstream planted site, but the plants are doing very well with a lot of leaf growth, and also a lot of cover, increase in cover inside the fence. And we're back out 116 days later. This is that same planted site, and the plants are still doing very well. The fences are holding up, so we were pretty happy with this. Another site, not all of the planted sites did as well right away, but you can see the plants doing good in some areas. This is site 2. We've got some open areas, but overall the plants are doing very well. This is into almost late August. And this is a close-up of the plants. I'm not sure which site this is, but you can see the plants, the leaf length was about 6 inches when installed, but they're much longer and also much denser. So we were real happy with this too. So move on to, in September, there was some additional work contracted out by the foundation. We decided to try a slightly different product that was coined as the burrito. It's a little different in that it uses a burlap sack instead of a peat pot. And the idea was that besides trying a different technique, but the burritos were a little bit more cost productive. So we got a little bit more plantings for our money. And this just kind of shows the scale of the burrito. So this is day 1 where the contractor is bringing out some for installation. Shows a close-up of all the burritos. And this is the contractor installing. The plants just kind of shows their technique for installation. And this site is one of the more downstream sites. And this is a close-up of the burrito product, doing very well so far. This is a good photo. It shows the plants. These are some of the original plants that were installed in April and May, but it shows several plants flowering, which was a good sign for plant health. You can see the spiral stalk. Some of the plants are flowering pretty much in the center of the photo. One of the biggest hurdles for us was the herbivores out there. Turtles love to eat eelgrass, as well as some fish and of course manatees, but the turtles were pretty good at getting under the fence or figuring out a way to get over it. So here's Rob with an herbivore that we had to remove from the fence. The maintenance required a lot of fence repair due to the amount of water moving through and storms coming through. And this is Rob in the water repairing a fence. Part of the new contract in September involved the contractor building new fences. Not sure which number this is, but they had built about 5 new fences. This is a finished product, a finished fence. And this just shows another example of the monitoring that we did out there on a regular basis, keeping track of survivability, and other notes regarding the fence. Fences were damaged in some areas. So then in October, we had a couple unexpected situations. A couple hurricanes came by pretty close to our planting sites. So we had a lot of water in the Northwest Fork. This is the most downstream planted site, so you can see the water depth is right at the top of the fence. And we also had, unfortunately, some fences damaged by the wind and the volume of water moving through. There's another damaged fence. Another damaged fence. But several fences did do well and with some minor repairs. This is one of the original fences, but water levels are very high in this picture. So recently, Rob and I went back out for an update for another monitoring event, and we were concerned, with herbivores being able to get inside of the damaged fences, but we were happy to see that in several fences the plants are still there. They're very small because of herbivores, but they are still there in several fences. And this just shows you an example of the eelgrass that we saw recently. It's very small, but it is surviving, so that was good news. And then I think this, I'm going to switch it back to Rob for a minute.
Okay, yeah, Rodney. Okay, you want me to share
Sure.
my screen? Okay. Let me see. I got to do a dance here. Okay. Okay, so what are some take homes here? Or what is the take home message? All right, we still good, Michelle?
Looks great.
Okay. So I would say overall, the project worked. We have proof of concept. We learned a ton of stuff, and it is complicated. So I think so. And Rodney, feel free to jump in here at any moment. So one complication was fencing. Just with flow, some of the fences got pushed down. We think the herbivores as well, especially the tilapia fish, once they're able to get in, I think there was a question on the chat. I tried to answer some of those, but if the tide or just the water in the river was too high, the turtles are able to get in and out, the tilapia are able to get in and out. And if they can't get out at a particular time, they just kind of wait for a higher tidal cycle. So they get in and out that way. There were other challenges with the fence. So possibly that picture of me and the turtle, they're actually going underneath the fence. So there were some design improvements that we made. But kind of zooming out just a little bit too, just having different conversations with different folks. Just overall, the system is kind of complicated. So we think that possibly in the 2010, 2011 time period, if you're local, you might remember that was the last time we had freezes, and possibly that affected the tilapia, which is why all that eelgrass was released post 2011. And then was kind of flourishing in 2017. Then in 2017, Hurricane Irma came through, and whether all that water just created a bad situation for the eelgrass where it couldn't photosynthesize, where there were some other things going on. We're not sure, but around Hurricane Irma, which we really only got rain. From that's when the eelgrass disappeared. Some of the stuff that Rodney was showing is there's a seasonal effect, we think. So while it's true that some of the herbivores, are definitely able to get into some of the fences right now, some of them are down, but some of them aren't. I think that there's just a seasonality to the growth of that plant. And so we'll be able to see that in the spring. Does it put on a bunch of new growth? Is it just, you know, certainly hasn't been cold, but it just may not be growing as well, or it could be related to light as well. Maybe there's more water in the river right now, and plants can't photosynthesize. Water depth, and then the flow also complicates, you know, whether it's the fence or again the photosynthesis of the plant. So you know, overall, again, proof of concept is there. It is complicated, but we're working on some of these things, and we might be able to alter some of these things. So we can talk about that if there's questions about that. But again, overall, plants are alive. There's a bunch of them out there. Right now, they're not super impressive in terms of size, but they're out there, they're alive. And we've learned a ton about all these different interactions, all these things that are happening out there that we wouldn't have necessarily had a clue about. And then kind of to Rodney's point, it's a super fun project. It was a ton of work, you know, kind of squeezing in time to fix fences and check on things and work with contractors. But you know, we got to go out on Monday. Monday was a beautiful day. What a great way to spend time in this awesome natural resource that hopefully we are going to be able to restore, and particularly the eelgrass in the river. And the plan is that we will try to continue, again, fixing some of the fence issues. We have different ideas on fences that we have. We've got cages, so they're much smaller, but we could just put over some plantings, and tilapia, turtles, whatever, won't be able to get in. So we have some different ideas. We have different things that we could be able to do. And then especially in the springtime, we'll be able to really see what's going on. It's still really challenging right now with all the water that's out there. It's kind of hard to see with the water depth and how murky it is. So Rodney, was there anything else that you had, or are we open it up for questions?
Just want to show the last slide though.
Okay.
We had several people, you know, helping out with the project from start to finish. So am I sharing my screen, Rob? Let's see. Can you see that?
Yep.
I'm trying to get to the last slide. Not having much success here. See. You may have to share yours, bro. Let's see. I'm getting closer. Oh. And I need to go back to, oh. Yeah, I mean,
I think that's good, Ronnie, if you just
yeah, I'm trying to get to that same spot again.
yeah, I think for just the last slide, if you want to go, I think that's fine.
Okay. Can you see that though?
Sure can.
Okay. So there were several people involved with the project and several different agencies. So I just wanted to list the foundation, of course. Palm Beach County Environmental Resource Management helped us out with the collection sites. Of course, Rob and the Park Service, and Irene with the Indian River Lagoon Aquatic Preserve, and other FWC staff, Tom and Beecham. And that's it. So we can go to questions now. And I'll stop sharing. Let's see.
Great. Well, thank you both. We had some great questions coming in. Rob, I know you've been engaging a little bit in the chat, but we're going to take that now on to the full conversation. So we have obviously Rob and Rodney to help answer questions in addition to Beecham. So let's get going. This is from Diana. She's asking what % of the total number of plants do you believe survive so far? Rob and Rodney, I don't know if you have a sense of that, or if it's too early to tell.
Yeah, so we've done, we planted in total 20 fences that had 500 of those, either the pea pots or the burritos. So that actually, so it equates to 10,000 plantings, if I'm doing that math right. And each of those pots or burritos had, anywhere between 3 and 5 plants. So somewhere between 30 and 50,000 plants, if I'm doing the math right off the cuff. It's a total guess, but I would say in the 10 to 20% amounts. And then actually there were also some plants that we free planted, so outside of fences. So it might be even be a little bit lower than that, like 5 to 15%. But they grow vigorously. It doesn't take a whole lot to fill up a fence. So there's still a ton out there. And then hopefully this kind of gets to I think another question of repairing fences and how long will the fences be up. Hopefully we'll see some establishment of plants outside the fences, and it could be directly outside the fence, or it could be in other areas once the plant is able to go to flower, which we did see, and go to fruit. So in my view, I think we're trying to create a place from where those plants will spread from outside of those fences. So I don't know if that's enough to answer that question, Michelle.
Great. Yeah, thank you. And Rob, apologies, you might have just answered this while I was scrolling through the questions, but how long, we have Diana about how long the maintenance of the fences?
Yeah, it's a little open-ended right now, but we're, we know that the fences are really important because of the tilapia. Not only, we talked about herbivory, but to me, it's a little unclear with tilapia how much herbivory they're actually doing, versus they just kind of create a bare patch of soil for like reproductive purposes. So I mean, we don't want that fence out there any longer than we have to have it, but it's probably going to be at least another year.
Okay. And I just wanted to point out, this conversation was happening in the chat in case folks missed it, but there were some questions to make sure that the turtles, like the one Rob was holding in the photo, that that those are able to get outside the fences and they're not seeing mortality. And I just wanted to share that Rob did comment that he hasn't seen any mortality with the turtles. So no turtles were harmed in the making of these plantings.
Yeah, and basically if they can get in, they typically get out. So we've had issues initially in some of the fences, just we just missed that the turtles were actually getting up underneath some of the fences, so we fixed all that. But then when the tide or the water level is higher, they just dive right in. So just depending on how they were getting in or out, they're okay in there because they can get right out. So so that is a tweak possibly that could be done is the second set of fences was built maybe a foot to maybe in some places 2 feet higher. So we might need another foot or two above that to keep more stuff out, and that's something that we work on the the fence design and the contract procurement part of it. So we've definitely learned a lot there.
Great. This might be a question more for Beecham or Rodney, but we had a question from Robert asking just about how eelgrass is propagated, seed cuttings, tissue culture. If somebody wants to take that question, and I don't know if either of you, if your cameras are still off from presenting, so if you wanted to turn those on.
Okay, this is Rodney. I'll give it a shot. So we mentioned, I forget what slide it was, but eelgrass reproduces in a couple of different ways. One is just the runners, which is an asexual reproduction where the plants just basically spreading into new areas by roots or popping up, floating up and spreading downstream or to new areas of whatever resource. The other reproduction technique or strategy is flowers. There's two types of flowers, and when the flower is fertilized, the plant actually creates a seed pod and eventually spreads those seeds. So I hope that answered the question.
Yeah, thank
Just
you.
super quick on to answer the question about the propagation. We collected whole mature plants. I answered this in the chat, but we collected whole mature plants from 2 different sites within the watershed, and then grew those out. The contractor took those back over to his nursery, grew out the plants for about 3 months, and they were in 4-inch peat pots, and then they essentially took a little 6-inch square of burlap, put the soil matrix in it, and then put 3 eelgrass plants. So in total, we did, I think, 7,500 peat pots, so 30,000 plants in the peat pots, and then 10,000 burlap or burritos with 3 plants each, so 60,000 plants. So if we even got 10% survival, let's grow the best. Planting.
Beecham, oh, there you are. I think we lost you for a minute, Beecham.
Okay. I'm not sure if you
Thank
heard
you.
what anything. I don't know.
I think we got most of it. Yeah.
I don't know if we had better production, better growth in the north part of the river, where the water was maybe a little bit clearer than in the south or the south half. Rob, do you have an opinion on that?
I missed it, Beecham. Sorry.
If you had better growth, less patchiness, more complete growth, on the north part of the area we planted versus the south part of the area we planted, and
Right.
if maybe it was soil or water clarity, because being the reason.
So yeah, so there's challenges. So I was working on the chat, so kind of goes with the question that I was answering there. But as you go from north to south, so that's upstream to downstream. So you have different inputs. Sort of the middle reaches of the river, or the more downstream parts, seem to be a little bit more. There's more organic material, and partially because of the drainages there. There's some sedimentation going on that we're in the process of fixing. It's kind of a multi-year thing, but there's less. So as you go upstream, it's more of a sandy substrate as opposed to muck, where if you go out, the mucky stuff you just sink, and then the upstream side is more sandy. The sandy substrate seems better. That's one thing. Also, as you go from upstream, it's more fresh water. Downstream, it's a little bit more saline, which isn't necessarily a problem, but maybe. And then the other thing is that it's kind of harder to see. So as you go more downstream, the water's a little bit deeper, it's a little murkier. So it's a little bit harder to evaluate like fresh plantings. But it definitely seems like the more upstream, whether it's salinity, substrates, whatever it is, right now seems to be growing better, closer towards trappers. But some of those pictures that I saw, that I showed you, I think all those pictures that I showed you were actually like those meadows of eelgrass. Those were in the more downstream sites. So it can grow there, may not be grown there as well right now.
Right. Thank you, Rob. That's super helpful. This kind of, you mentioned that you guys were, maybe this was in an email earlier, that you guys were out on site this week, and we had a question asking how often you go on site to check out the fence, do any repairs. Like, do you just want to talk a little bit about kind of that process?
Yeah, so the actual planting, I think initial planting and building of the fence it was close to 2 full weeks. So for 15 fences and plantings, it was, around 10 work days, might have been 8 or something. So we were there, all the time, kind of switched off, because that's a ton of time to be out there. And then I think we were out there weekly, and then we helped fix some issues. As time kind of progressed, we were having less issues because we fixed those problems. So we were able to go out there maybe every couple of weeks, maybe once a month. And then, so in September, we planted again. So we were out there again daily, and then, weekly, and then back to monthly. And then I think it'd been a couple months because we'd identified some issues that we're trying to get the contractor to fix. So there wasn't any point going out there, really, because the contractor hadn't gone out in a little while. So it just kind of depends. We do have a concessionaire, that riverboat tour. He's out there every single day, or if not every day, 5 out of 7 days of the week. So if there's some catastrophic issue, they pulled a big tree out of one of the fences, for example, after Hurricane Nicole.
Great. Thank you. Our next question is from Gary Jennings. Hey, Gary, nice to see you. He's asking about what caused the initial loss of eelgrass, and if outside the weather, has it been addressed?
What was the very last part of that, Michelle? Outside of the weather?
Has it been addressed? If whatever caused the initial.
I think initially the biggest thing was just the fences in places got blown down, or fences were, when it was planted, it was out of the water. The fence was out of the water, but so built like a lower tide or lower level of water, and then the water went up and the fish came in. So either the fence got knocked down, or herbivores were able to go in. But basically the two are the same thing. The tilapia came in and kind of partied in the fences and uprooted the plants. the
Great, thank you.
tilapia. And again, it's the thing that, you know, I mean, day to day, you know, you have a tidal cycle, but then, you know, you get a big slug of rain or something. Now the river is 1 to 2 feet higher, and then, you know, we were a little bit less sure on the design, so we've now been able to make sure those fences don't get pushed down because of the water coming downstream. We know
Yeah.
how to do that.
So Rob, quick clarification. I think Gary is asking about what caused the initial loss of seagrass, not necessarily, or eelgrass from not the planting, but like in the habitat.
Yeah, I mean, that is a great question. I don't know. I don't know if it, you know, it was around the time of Hurricane Irma, and Irma hit when we also had really high tides. I mean, I remember being out on the river, and, you know, downstream there were houses that were almost underwater on the river. So I don't know if we just had too much water in the river for too long. Maybe that's the reason the plants couldn't photosynthesize, and or that, so, you know, I think nothing is really simple here. That's what I've found out, is that maybe, you know, the plants had, you know, so it was in the fall, they're not growing as fast, you have all this rain, they're not photosynthesizing as much, and then, you know, now compared to 2010 and 2011, when we had the freezes hurt the tilapia. Now we have the normal amount of tilapia in the river, and tilapia are non-native, but we have the normal amount of tilapia, and the grass isn't as robust, you know, because it's stressed out, because all this rain can't photosynthesize as well. And so now it's easier, or there's less of it out there, and it's easier for the tilapia to dig all this stuff up. Yeah, that's the best guess. But it's a great question. I don't know that we know the answer.
Rodney or Beecham, any other additional guesses to add to Rob's?
Not for me. I think that was a great answer. Thanks, Rob.
Cool. Ryan wants to know, oh, we addressed that, Ryan. So let us know if you have an additional question, but Ryan was asking about how often you're checking on the plants, and I think we got to that. So Blake has a question about eelgrass. Does it grow in brackish water, like in the intercoastal waterways, or would that be a different type of grass? I know you, all three of you could probably do a deep dive on the different different type of underwater vegetation. So who wants to take that one?
In the further downstream areas by the inlet, it's going to be all seagrasses, and eelgrass is tolerant to some degree of salinity, but not those types of higher salinities. So it's also, things kind of change. So if JD is kind of the upstream area, there's a bunch of homes kind of in the middle reach of the river, and the downstream reaches of the river by the inlet, there's a lot of flat sandbars, sandy areas. That's where, in this system, that's where the seagrasses are. There's so the Northwest Fork, the North Fork, and the Southwest Fork come together. It's a big embayment, and in there there's seagrasses. It's just going to be too brackish, really too saline for eelgrass. So the eelgrass drops out before you get to the end of the park, So the beginning of the park is 6 miles upstream of the inlet. And so in the map from like, the 2011 to 2017 area, approximately eelgrass went to river mile 8, might be 8 1/4, 8 1/2. But those seagrasses are down at like, I don't know, I'm not as familiar down there, but river mile 1, maybe the half-mile marker from the inlet. And then obviously all up and down the intercoastal.
Great. Rodney Beecham, anything to add?
No, that was another
Okay.
great answer, Rob.
Rob's just knocking it out of the park here. So Morgan has a question. They joined us, they're saying they joined a little late, but they're wondering if there's been any correlation with the growth of the plants and any water quality data. Is that something, Rob, that I'm sure you're keeping an eye on, but I don't know if you want to say anything more about that.
So Loxahatchee River District does a ton of water quality data collection. And I think, I guess that the answer is we haven't been able to correlate that. The biggest thing is the substrate issue. That is, I'm just trying to think, like say we planted at river mile 8 1/2. That's the furthest downstream. The substrate is more organic in that area. That could be a natural thing. That could be with the mangroves right there. There are inputs to the river where we have a little bit more turbidity than we want. So those, like say river mile 8 1/2, plants didn't do as well, but there's some other things going on there as well. So it's hard to say, but certainly upstream in the Trappers area, river mile 10 to river mile 9, the substrate is sand, it's doing really well. But the water quality generally in the Loxahatchee River is really, really good. So again, my little sandbox is Jonathan Dickinson State Park. We're lucky that we have good water quality. It's not the water quality that's coming out of the C-44, out of the St. Lucie Canal. So even our bad water is pretty decent, especially by the time it comes to the river.
I'm keeping an eye on the clock. I think we have time for the last 2 questions. If you have any additional ones that pop up and we haven't gotten a chance to address them, or you think of something, don't hesitate to send me an email. You can just reply to the email that you received the Zoom information on, and I can pass them along to Rob, Rodney, and Beecham to get you answers. So we have a question from Blake wondering if we consider that the 15 to 20% success rate of the plants that have survived to be normal, or is that higher or lower than your expectations?
I can take that one, and then either Beecham or Rodney can take the genotype question if we get to it.
Sure.
So, obviously we want 100% success rate, but we knew that wasn't going to happen for any number of reasons. We didn't, I don't know that we had an expectation. I would say that are we, the question, I'm trying to read it, are we happy, or would you consider 15 to 20% success rate to be normal? So okay, yeah, so the way that I'd answer this question is that if we didn't put up fences, we would have had 100% mortality rate, right? So so having that 15 to 20%, I think is good. We know the fences work. What we need to do is improve that fence, make sure it works better than it did. Maybe build it higher, maybe have these cages, you know, whatever it might be. And then hope that we can get, you know, 10 to 15 of these fences, you know, with very robust plants that then spread that plant to other parts of the river. So, so yeah, no, I think some of the plants are there. We're happy with it. We're going to build on that. So hopefully that answered that question.
Yeah, thank you, Rob. All right, last one. So this is either for Rodney or Beecham. Are you concerned with the diversity of the eelgrass genotypes? Do you collect in a variety of locations, or plan to outside the river park?
Well, I'll give it a shot, and Beecham may want to add to it. He has more experience with eelgrass projects overall, but the plants were collected from 2 sites within the watershed of the Loxahatchee River. The collection sites were pretty far apart, so there probably is different genetics involved, and yeah, more genetics is probably better. And I believe I mentioned during one of my slides, during our monitoring events, we've kept track of which genotype or ecotype was installed in each fence. We only installed 1 type within each fence. I hope that partially answered the question.
Yeah.
Beecham, you may want to add to that.
Well, we try to collect within the watershed, and we collect different, like you said, from 2 different sites. And our research group has found there is the native Vallisneria americana, and then there's a hybrid Vallisneria that's Americana, and I don't remember the other scientific name, but it's Vallisneria. And Rodney collected plants from, one was a C18 canal, one was from, Rodney, you can tell them the other side, I can't remember the exact name. And then he also collected plants that were in the river itself, or in Northwest Fork. And what he found was that plants from the C18 were native Vallisneria. Plants from the other site were the hybrid, and the plants from the river were also hybrid. And what we're finding is there are a lot of people that just throw their plants back in the water, and that's especially in South Florida, and South Florida grows plants like crazy. So yes, we are concerned. We want to take plants from as many sites as we can, but we want to be planting native Vallisneria americana, not the hybrid species.
Thank you. That's super interesting. So I want to be respectful of everybody's time, because I know an hour in the middle of the day is not nothing to give up. So I appreciate you doing that, especially during this busy season. I see these, if I dropped a survey in the chat, if you have time to just give us your feedback, what you thought worked, what didn't work today, what you want to see more of. That's really helpful to us in planning these. Really appreciate our 3 presenters, Rob, Rodney, and Beecham, not only for their time today, but for all their work on this project. Just really grateful, and grateful to all of you who not only joined us today, asked incredible questions. Many of you have donated to fund this effort. So we're just at the foundation can't thank you enough. Guys, I don't know if you have anything else you want to say before we sign off.
No, I'm good. Thank you, though.
Great.
Thanks everybody
And
for joining. Thanks, Michelle.
My pleasure. Thank you. And if anybody joined late, or you have friends that you want to make sure you see this, we are recording. We'll share that recording with the same way that you got this Zoom information, both in our eBlast and on social media. So keep an eye out on that. And we'll look forward to talking to you next time. Thank you again, everybody.